Hello, and today's learning target is I can identify the correlation of a scatter plot. I can identify the line of best fit, and I can use the line of best fit to predict a future outcome. So let's first look at what exactly is a scatter plot. Well, a scatter plot is a way to represent a lot of data points. So if you can see the two scatter plots shown, that shows the height versus the weight. So for example, as the height of an object, a person, an animal, as the height goes up, here the scatter plot's telling us perhaps the weight will also go up. And again, you can see that with the data points there. The next scatter plot, has price and quality listed. So as the price goes up, perhaps the quality of an item would also go up here. And it's not just one or a couple specific data points that tell this. There's a lot usually that you can see. They're scattered all about. But again, that's what a scatter plot represents. It's just a way to show a lot of data points. A scatter plot can have different types of correlations, meaning that one variable is likely linked to the other measurement. And there are different types of correlations. So a positive correlation looks like, the trend of data points is going in an upward direction from left to right. So if we were to draw a line through this, the majority of the data points would be going in a positive trend. And so what this says here is, as student grades or as time spent studying goes up, so do student grades. So that's what a positive correlation looks like. No correlation means that the data points are scattered about. We could not draw a line, anywhere. It wouldn't make sense for us to represent the data points, in a certain type of direction or say that there was a certain type of correlation because there's not. It's just totally scattered about. You can't draw a conclusion from it. Lastly, negative correlations. So if I were to draw a line in, and this is called the line of best fit, which we'll practice in a little bit. If I were to draw a line in, that would go in a downward trend from left to right. And so here, this says, as the elevation decreases, the annual temperature also decreases. So that's what a negative correlation there would say, and what it would look like for a scatter plot. So again, these are the three types of correlations you will see within a scatter plot: positive correlation, no correlation, or a negative correlation. We can also take a line and kind of fit it to the data. This is called a line of best fit. So we will look at the study of grades and time studying that we looked at for a positive correlation on the last slide. Let's approximate the line of best fit. You want to try and draw it as the average of all the points. So as I draw in my line of best fit, I want to do my best with going, between the middle or in the middle and through as many points as possible. And as you can see, it's better with a straight edge. My stylus sometimes isn't as straight as what I could have with using a ruler, but you want to, like I said, try and go through as many points as possible, but also have it be the average of all the points. So in between, as many as you can get through. Now, it doesn't have to be perfect, but you also want it to be pretty accurate. And so this year, you will not be asked to write the exact equation for the line of best fit. This is a complicated formula and a process that you will learn in high school, most likely in a statistics class. You will be asked to estimate a line of best fit, and that's what we'll practice here in these notes. Okay, so let's look at an example here of money earned from babysitting. So this correlation it looks like it's a positive correlation, which makes sense, right? The more time babysitting, the more money to be made. So let's draw in a line of best fit, and then we are going to approximate what that line of best fit is by choosing one of these four options over here that would represent our line of best fit that we have drawn in. So let's go ahead and and again, it's really good with the straight edge ruler, but with your line, you want to try to go through as many points as possible. And sometimes, it takes some time to practice. But again, you want to tried it to be the average of all the data points, and it goes through about the middle, as many points as possible. And again, you will not be asked to calculate the exact formula for the line of best fit, or be asked to do that right now. So we're just approximating. So as we look at this, it looks like the y-intercept, and I'm going to highlight this, is right about, it's like a little over 1, close to 2. That's what it appears to be for me. So as we look at the available options, number 1 is y equals x. That means the y-intercept is 0. I would definitely not say our y-intercept is 0. Number 2, y equals 2/3 x plus 1. Could potentially be that, right? Because it looks like it's about 1 for a y-intercept. Number 3, y equals 3/2 x plus 4. Okay, so I'm going to say no to that one because 4 is a little bit too high for the y-intercept. And then number 4, y equals 3/2 x plus 1. That could definitely also be a potential option. Okay, so so 2/3 versus 3/2 of a slope. So for example, if I went up 2 units and over 3, is that on our line? Not quite, right? But if I go up 3 over 2, is that on our line? Looks like it is. Now again though, it depends on how you drew your line of best fit. If we did think about, a line of 2/3, that would be a line like this. Up 2 units over 3, if we did 3/2, up 3 over 2, that's definitely a steeper line, which is what appears that our line is. So again, some of these options are close, and you gotta have your, best approximation and look at the information you're given. So 4 is the correct answer to this problem, and we could conclude that too based on the slopes that we found from our line. And if we were looking in which would be the closest slope, 3/2 would definitely work over the 2/3. So again, this was approximating a line of best fit by drawing in our line of best fit, as well as we can, and then approximating the y-intercept, calculating the slope, and then figuring out our line for the equation for the line of best fit. Okay, let's look at applying a line of best fit and approximating the equation for the line of best fit. So, the amount of time spent studying and the score received on the exam in Mr. Dillon's class are as follows. And so if we look at this graph here, that's how we can see the amount of time studying versus the score with this scatter plot right here. Number 1 says draw a line of best fit. So on our paper right now on this scatter plot, let's draw a line of best fit as best we can approximate this. All right. And again, I know sometimes these lines aren't as straight, but I think that looks pretty good. And actually I want it to be a little bit better like that. So I would say that looks like it's about the average between all of the points. So let's go back to our questions that we need to solve. So draw a line of best fit. We did. Number 2, approximate the equation of the line of best fit. Well, again, this will be in slope-intercept form, so y equals, now I need to figure out the slope, so something x, and then I'm going to approximate that y-intercept, and it's about 50. So I'm going to say y equals my slope, something x, which I have to figure out still, plus 50. Well, let's take a look at our graph. And so now if I find my slope, rise over run, so I maybe would use a couple points here where I may go, so this is a little bit below 50, so I may go up to this one that's a little bit below that line right there. And I might say up 1, 2, 3, but that's really 15 because it counts by 10, so I went up 3 lines, so that's 15. And then over there, 1, 2, 3, 4, 5. So I went up 15 and over, well, really I went over 5 lines, but that's really 3 if you can read if we read the axes right. So 15 over 3 simplifies to about 5. So the slope would be about 5. And again, this is just an approximation. So y equals 5x plus 50. And so as long as we're somewhere around, what would the correct slope be, we're going to be just fine. And so this was a good approximation for our line of best fit. So y equals 5x plus 50. Okay, question 3 now says approximate the percent when someone has spent 4 hours studying. So now I'm going to plug in 4 for x. So y equals 5 times 4 plus 50. 5 times 4 is 20 plus 50 would equal about 70%. And now this also makes sense because if we look on our graph, if I go over 4, where does it about up to right there? Well, that's about 70%. So that would fit here and make sense for the answer that we got here to approximate the percent when somebody has spent 4 hours studying. All right, question 4. If someone were to study for 10 hours, what would be an approximate grade? Okay, so if I now plug in 10 for x, y equals 5 times 10 plus 50. Now, 10 hours is a long time to study. So let's see what we get. 5 times 10 is 50, plus 50 would be 100%. So what this is saying is if studying for 10 hours, and if we look at our graph here, somebody should be able to get 100%. Now, is that realistic? Well, maybe. I mean, studying for 10 hours is a long time. I would hope that if you studied for that long, you would be able to have the material mastered and could get 100%. All right. If someone studied for 20 hours, what would you predict their score to be? Is this reasonable? So if I plug in 20 and solve, 5 times 20 is 100 plus 50 would equal 150%. Now, think about this. The percent of the test, and we can see from our graph, goes up to 100, right? 100%. So this would only be possible if there was extra credit given, right? And, there may not even be extra credit given on this test. So is this reasonable? Not really. But the more you study, right, should correlate to perhaps the percent that you get on the test. The better the score, the more material learned. However, 150% is not necessarily reasonable unless there was enough extra credit given for that to actually be possible. Okay, so to wrap up what we reviewed right here is we went through a scatter plot example, just a general overview here. Thanks for listening to the video on scatter plots. Have a great day. Bye-bye.